So here's a question, finding the area of the shaded region. To be able to find the area of the shaded region here, the first thing you need to do is figure out what's the area of the unshaded region. So the area of the unshaded region, I'm just gonna make it, that would equal the area of the sector minus the area of the triangle. Because the sector is all of this right here, and you want to take away the area of the triangle, and that will give you that unshaded region right there. Once you find that, then to find the area of the shaded region, you'll do the area of the circle minus the area of the unshaded region, and then you'll get the area of the shaded region. Now, they want this answer in exact values, so we're going to work with exact values. So let's do one thing at a time. So the area of the sector, we know it's half r squared theta, and theta has to be in radians. So let me just show you a few things that were given here. So they've given us the radius here is 1, and they said this is an equilateral triangle, which means all the angles here are 60. So 60, 60, 60 degrees. So the area of the sector would be half times the radius 1 squared times theta, which is theta here is 60, and 60 in radians is pi over 3. So it will be pi over 3, which equals 1 squared is 1 times a half is a half, half times pi over 3 is just pi over 6. So that's the area of the shade of the area of the sector. So this is the area of the whole thing here. And the area of the triangle, we know it's base times height divided by 2. Now, let's just look at this triangle right here, and I'm just going to draw it right here, okay? And I'm going to bring a vertical right there for the height, which is this one here. Now, we know the base here is 1 because the base is right here. That's 1, since all of these are 1, this is 1 as well. So all we need to do is just find the height, okay? So we're just going to use the 60 degrees to find the height, and using trigonometry. So the height here, if we want to find this, we could go, I'm just going to say from here to here is a half, okay? Let me just make that nice and clear. So this, if this is 1, then this part right here is a half. And therefore, if we're finding the height, we go sine 60 and we know this is 1. Yeah. So if we want to find the height here, we could do sin 60 equals the opposite, which is the height over the hypotenuse, which is 1. So basically sin 60, which sine 60, if you look at the special angle triangle, sine 60 is opposite over hypotenuse. So root 3 over 2. And h divided by 1, just h. So the height is root 3 over 2. So now let's plug everything in here. So the base of the triangle, as we said, it was 1 times the height, which is root 3 over 2 divided by 2, which gives me root 3 over 4. Now, can we say now the area of the unshaded region, which is that here, equals the area of the sector, which is pi over 6 minus root 3 over 4. So as I said, the area of the sector minus the area of the triangle. And you remember its exact value, so that's why I'm not doing that in decimal. Now, once we found the area of this right here, now we need to find the area of the circle, which is pi r squared, which is pi times 1 squared, because the radius is 1, which gives me pi. Now, if we want to find the area of the shaded region, we know it's going to be the area of the whole circle minus the area of this little piece, which is the unshaded region, which is that. So therefore, the area of the circle, let's just write this, the area of the circle minus the area of the unshaded region, which looks like this, which gives me pi minus, in brackets, pi over 6 minus root 3 over 4. That will give me pi minus pi over 6. That's, if you want to do common denominator, that's 6 over 6. 6 pi over 6 minus pi over 6 is going to be 5 pi over 6. And this negative is going to change that negative to plus root 3 over 4. It's a question that looks a bit complicated, but it's, as a matter of fact, it's pretty simple. Okay, and that's the final answer. As always, thanks for watching. Till next time, bye-bye.